Okay, good morning, friends. It is, from my calendar, is Thursday, April the 9th today, and so we just finished chapter 9, and chapter 9 was all about probability. And again, if you're needing some extra help on this, Zoom with me. Let me go over quizzes with you. Let me explain things, but you've got to reach out to me. So the last thing, so basically we have 2 sections left in this class. And so you're almost there, so don't give up on me now. So in chapter 10, we want to look at statistics, okay? So some people use probability and statistics as the same, but they're not, okay? Probability is always less than 1. Most people change it to a percentage. Statistics is where you take data and look at it. Okay, take data and look at it. So today what we want to do is we want to introduce statistics, and we want to focus on statistical charts and graphs. Okay, and I will be real honest and tell you that charts and graphs are a major part of, you will see this anywhere from pre-K through 8. Okay, it starts out just looking at things, looking at pictures, putting things in order, ordering things, and then it slowly goes to creating graphs and reading graphs, and so this is a big part. So you being able to create an efficient chart, or being able to know if it's an efficient chart or graph for you, is going to be important, and then teaching your students how to read graphs. So what today is, it does look lengthy because it's 15 pages, but it's just going through the different types of graphs that are available and when they're appropriate. Okay, so there's not a lot of writing, it's more just emphasizing a couple of things. So statistics is the branch of math that deals with the collection and summarization of data. Okay, so a graph is a picture that displays data, and here are a lot of your options. We'll look at all of these except a box plot. We won't go into a box plot, and we won't go into a frequency polygon. Okay, but the rest of them we'll look at. Excuse me. Okay, data is observations that are measured, that have been collected. So there are 2 types of data, and the 2 types of data are what determines which graph is or chart is appropriate. So you want to make sure and know, okay, what type of data do I have? So our 2 categories are categorical data and numerical data. So when we think about categorical data, it represents characteristics. So usually numbers don't make sense here. Averages don't make sense. So categorical data would be something like, are you Democrat or Republican? Are you a male or a female? Are you, what is your major? Okay, things like that. So it's categorical. It's not, what is your eye color? What is your shoe size? What is your, those kind of, are you wearing a t-shirt, a long sleeve shirt, a sweatshirt, those kind of things. It's not something that averages make sense on. Okay, so that's categorical. Numerical data is where we look at something to do with numbers. Okay, averages do make sense. Miles per gallon, average temperature, number of meals served, GPA, age, income, those are all things where numbers make sense. So that's numerical data. Okay, so the first type of graph that we're going to look at is a pictograph. And a pictograph uses tallies of categories. Now, it's usually determined by a picture of something. So this one is a picture of a car. Okay, and one car represents 100 cars. So you can look at the graph and say, okay, in February they sold 100 cars. Now, a couple of things about a graph in general. Number 1, it must have a title. Must have a title. Number 2, your axes of the graph, so what's happening on the up and down and what's happening on the bottom must be labeled. Okay, so this one has months and this one has numbers sold on the bottom. Must be labeled, so you must have your axes labeled. And then the second thing, or the last thing is it must have a legend. And what the legend means is it's a symbol. It's something that shows you what each piece means. So in this case, each car represents 100 cars. So that means your legend is that portion of the graph. So usually it's underneath the title or off to the side of the graph. And we'll see those throughout as we look at these. But you definitely want to make sure you have a title, make sure your axes are labeled, and make sure you have a legend. So this is a pictograph. The next one is a dot plot. Okay, so a dot plot, you can look at it, dot plot for test scores. So basically it's a number line, and you have your dot plot, or it's also called a line plot because you're using number line, but you have your scores lined up on top with the X's. Okay, so you can see all those scores there. And as we continue, you can see the X's, you can account for 2 students scored a 72. We have what's called a mode, and mode means the most. So here you can see that the 4 students scored an 82. So my mode would be an 82. That was what the score that happened the most. We also have gaps. So gaps occur. There's a gap right here that came from an 89 to a 97. Okay. There's also a gap down here. Another term is called an outlier. So a score that maybe sits away from everybody, this guy would be an outlier down here. And then a cluster. So these scores right here would form a cluster. These scores right here in 80 to 85 would also be a cluster. Okay. Vocabulary is going to be very important in this chapter, so make sure that the definitions are listed right here for all 4 of those things. So definitions are important, so make sure you're definitely keeping track of terms. The next one is a stem and leaf plot. Okay, so what it means, stem and leaf, means you're going instead of having your number line going horizontally, you're now looking at it kind of vertically. So we still have our scores, but we have what's called our stem, and this piece over here is what's called the stem, the 5, 6, 7, 8, and 9. And if you notice, that's all the tens place of all of your digits. So my lowest is a 50, my highest is a 90 some. So those are the stems. Your leaves are the ones place. Okay, so I have a 56, a 68, a 72, a 72, a 73. So this portion is called the leaves. So this is just another way that you can display data. Again, we have a title, we have our stem, we have our leaves, and we have a legend. 9/7 means 97. Okay, and it also gives you directions on how to make a stem and leaf plot. So be sure to practice one of those in the homework. Here's some advantages and disadvantages of the stem and leaf plots. I'll let you read through those. And again, that's for numerical data. You can also do a back-to-back. So if she had 2 classes, you could have your stems in the middle with your leaves for one section, leaves for the other section. So you can also compare there what's going on. So a stem and leaf plot. Frequency table. So a frequency table has intervals in the first column, tally marks in the middle, and then the frequency on the right. And frequency means basically how many tally marks are falling in that interval size. So the thing to remember here, and then you can kind of look under, your interval size should all be on the same size. So these are all in, your interval size is 10. So 40 to 49 is 10 spots. And you can look down below to determine how that, subtracting your lower point from your higher point and adding 1. So that's how big they should be. Okay. Also, your intervals should not overlap. So if you notice 80 does not overlap up into here, 89 does not come into this one. They should be a set interval, so interval size. Histograms and bar graphs. So these are 2 different things, and the thing you have to remember is a histogram is adjoining rectangles. Adjoining rectangles, so they touch, okay? They touch here, and frequencies are shown by how tall they are. So this is a histogram. Now, a bar chart are rectangles that do not touch, okay? A bar graph. So also there's no ordering along the categories. So a histogram, if you're going to use a histogram, the ordering along the categories is labeled. So 40 to 49, 50 to 59. So these are in order if you're using a histogram. If they're categorical, so most of the time it's categorical if you're using a bar graph, there's no order to these down here. Okay, so make sure that you understand the difference between a histogram and a bar graph, because those are 2 that people struggle with. Okay. You can have a double bar graph. So you are comparing juniors and seniors. Okay, and the reason this is not a histogram is because you have, they're not touching. You have your junior, seniors, they're not touching there. Okay. A line graph, so a time series plot. So, so looking at something over time, and this is usually used with continuous data. So they're using weight here of a sheepdog. So it's starting at a certain and then going up. So if it's a line graph or a time series plot, that means that your points are going to be connected. So connect the dots to form the line. Again, a title, make sure you have your things labeled. The next one is a scatter plot. So with scatter plots, you're just plotting points basically on where things lie. So this is a lot, same idea as plotting points basically in algebra. The thing to remember here is most of the time when you're doing a scatter plot, they're also wanting you to look for trends. So a trend line, is it increasing, is it decreasing, or is there no trend whatsoever? So think back to slope in college algebra. If you have a increase from left to right, okay, the trend line has a positive slope, so you can kind of see it growing there. A negative association is it decreases from left to right, so you can kind of see how those price of movie tickets versus the number of people attending. So the higher the price of the movie ticket, the lower the number of people attend, so a negative association there. And then sometimes you just have no association. Okay, so they're just scattered all over. So that's not number of calories consumed per day and your IQ. Okay, those two are not connected whatsoever. So next one is a circle graph, and this is always used for categorical data, and it always has percentages. So if you make a circle graph, make sure that you have percentages listed there, what type. Again, you'll have a title. And then differentiated around. And again, your circle should add up to 100%. 100%. Now, choosing the right display, you can go through these and kind of look. I'm not going to read them to you, but which one, if you're given a set of data, what's going to make the best graph? And know that two may work. Okay, so you can show your data in different lights based on the graph. Okay, or based on what you think works best. Sometimes data is easier to read in certain tables and sometimes it's just not. So again, choosing the right display, what works and when to use it. So the key here for this section is to make sure that you understand what your types of graphs are. You understand if you were asked to create one, okay, could you create it? And then the second thing is reading the graph. Okay, reading the graph. So can you understand a graph? Can you create a graph? Can you read a graph? So that's the important thing about this section. So next week, we're actually, I'll give you a quiz in my math lab over graphs. And so next week we will do that. And so hopefully that's something that you can be successful at. So, because I know most people read graphs beautifully. So again, if you have any questions, please reach out. I don't mind visiting at all, and I don't mind helping you work through things, especially with probability, because I know probability is tough, but yet I'm not hearing from you guys. So please reach out if you do have questions. Have a great day. Happy Easter. Have a great weekend. I know it looks different than normal, but we're going to make it through. So happy Easter.